Okay, hi everybody. We are talking about section 7.1 again, but this is part 2. We are going to talk about the distributive property and solving equations. Once again, much of this stuff, or really all of it, is review, but we're going to make sure that we really understand this. So what we are trying to do today is to learn to use the distributive property and other techniques for simplifying in order to solve equations. Okay, so our end goal is to figure out, well, I've got this equation, I want to know what the value of the variable is. Okay, so let's get right into it. First of all, we've got to do now. This will remind us of what we were doing last time. So I welcome you to pause the video right now. Try to answer all 4 of these on your own. There's nobody laughing at you if you get them wrong, and then unpause the video. We'll see if you got them right, okay? So, what we have here first, 9x and 4x, these are like terms because they both have an x raised to the first power, okay? So I have 9 minus 4 times x. 9 minus 4 gives me 5, and so that's how many x's I have. I have 5x, because 9x minus 4x gives me 5x. Okay, next thing I'm going to do, number 2, I'm going to look for my like terms again. I see that I have 7 and minus something. There's no number written. When there's no number written, I know that's really a 1. And then my other one, this negative 9, that's a different term, because it doesn't have a p. So I'm going to combine the ones I can. That's 7 minus 1. Or, I'm sorry. Let me undo that. I have 7 minus 1, and those are p's, and then I will take away 9, which is an unlike term. Well, 7 minus 1 gives me 6, so I have 6p, take away 9. I cannot combine it any further because those are unlike terms, and so that is my answer. Okay. Number 3. I'm going to look for like terms. I see I have an x squared and another x squared here. And then I have a y and another y. So these I can combine separately. I have 5 plus 4 of my x squareds, plus I have 3 minus 2 of my y's. Well, 5 plus 4 gives me 9 most of the time, so I have 9x squared, plus 3 minus 2 gives me 1, so I have 9x squared plus 1y. Only one thing to do, and we can check to see if we can combine any more of these. We can't because they are different variables. I have an x and a y. But what I can do is I can say, you know, this 1, this doesn't really do a lot for me because I know if I just write y, it'll be understood that there's a 1 there. So I'm going to rewrite this to say 9x squared plus y. And that is as simple as I can make that expression. Okay? And now I go on to the fourth one. I have that 7g plus 5h minus 12. And I don't know anything else about it. I just have those 3 terms. Only problem is, this g, I look for any more g's, I don't see any more. So I go on to my next color. I have h's. I look for more h's, I don't see any. And then this minus 12, there are no other terms that don't have a variable. So the simplest form I can make it is 7g plus 5h minus 12. None of these are like terms, so I cannot add or subtract any of them. And that is as simple as I can make it. There was no improvement I can make on that expression. Okay? Now we're going to talk about the distributive property. We have mentioned it before, but we're going to talk about it again. What the distributive property does is it deals with parentheses and terms inside of parentheses that are added or subtracted. Okay? In this expression here, I had 5 times, in parentheses, 2 plus 3. Now, normally what you would do is you would say, or what you have been doing for years, is you say, okay, we do what's in parentheses first. So I have 2 plus 3, so I'll do 5 times 5, because 2 plus 3 is 5. And now I will multiply those together to get 25. Well, that's great. But it's not always that simple when we start using algebra. So we need some other rules that will help us simplify things. And here is the first and probably the most important one. If you learn nothing else about algebra and you remember the distributive property, you're doing better than if you hadn't learned anything. Okay? So, if I have this expression here, 5 times 2 plus 3, I can rewrite it as this 5 here times, it's getting a little bit sloppy, so I'm going to erase this. I can rewrite it to say that this 5 multiplied by the 2 plus 5 times 3. 5 times 2 plus 5 times 3. Okay, so let's make sure that we understand where this all came from. This 5 on the outside, it's saying this 5 gets multiplied by everything, so that's where this 5 and this 5 come from. This plus that's in between them is where this plus here comes from. If it was a minus, then we'd have a minus in between them. And then finally, we have the 2 that goes over here, and the 3 that goes over here. Okay? Once again, I'm going to erase this so that we can see it a little clearer. And we'll see what actually happens, because we know that 5 times 2 plus 3 should give me 25, because I got it over here in the way we're used to. Let's see if I get the same thing over here. I get 5 times 2 is 10, plus 5 times 3 is 15. What's 10 plus 15? Well, most of the time that's 25, and I did get the exact same answer. So I know that this works. However, I'm pretty sure we're not convinced that this is easier yet. In fact, a lot of people are probably saying, Mr. Duncan, I have no idea what you're doing. Why are you making my life so complicated? Well, here's the reason why. Because a lot of times we're going to have expressions like this, a times b plus c, where you don't know what any of them are, or maybe you only know what one of them are. And you need to be able to rewrite this. Well, if you do a times b plus a times c, you can rewrite this expression a little bit differently, and sometimes this will help us out. Let's do some examples, and I'm hoping that we'll get this after we do the examples. But before that, I just want to go over this one more time. Here's the way we will rewrite this. I have some number, in this case a, outside of a set of parentheses. That number will get multiplied by each thing inside. So a times b and a times c. Let me take a different color arrow here. I get a times b, that will give me this term here. And then a times c, that will give me this one here. And the sign that goes in between here is the sign that was in between the two numbers in the parentheses. Okay? Now, let's see if we can do some work with this and maybe make this make sense why we're doing this. So the first thing I want to do is I want to simplify this expression here. But I'm automatically stuck if I don't know about the distributive property. Fortunately, I do know about the distributive property. I know that 6 gets multiplied by the y first to give me 6y. And then 6 gets multiplied by the 8 to give me 6 times 8, which is 48. And then I know that the term in between them is this right here, this plus. So I get that 6y plus 8, or this original expression, 6 times the quantity y plus 8, will give me 6y plus 48. Okay? So that's what this became. And now I have 5y, this minus 5y, that just drops down. Now I will look to see if I can simplify this expression anymore. Well, I look for like terms first, and I do find some. I've got this 6y minus 5y, and I know that those are like terms because they both have a y in them, raised to the first power. So I can say 6 minus 5 gives me y, or 6 minus 5 times y plus 48. I know that 6 minus 5 just gives me 1, so I have 1y plus 48. And I know that when I have 1y, I don't really like writing y. I don't like writing 1y, so I will just write y plus 48. So I have this y plus 48, and that is what's left of this whole complicated mess that I started with. Let's look at it again without these colors here. I had 6 times y plus 8 minus 5y. And all of that ugliness turned into y plus 48. That's why we need to know how to use the distributive property. Okay, let's go over another one. I have this simplified 3 times c plus 7 minus c. And what I'm going to do is first I'm going to give myself a little more room. Okay. Okay. Got a little bit more room here. And now I'm going to work on number 2. Okay. So I see I have parentheses and some number that's being multiplied by those things in parentheses, so that tells me I'm going to use my distributive property. I have 3 times c, and separately I have 3 times 7, which gives me 21. And I know that I have this plus sign here that just drops down. So I have 3c plus 21. And I cannot forget about what came after here, this minus c. So here's my expression, what's left. 3c plus 21 minus c. But I'm not done yet because I notice I have some like terms here that I can simplify. This 3c minus c. And how many c's were there at the end here? It was minus 1c because there was no number here. I know it's a 1, a minus 1 in this case. So I have 3, take away 1, times c. That takes care of this one and that one. And then plus 21. I'm just about done. I know that 3 minus 1 gives me 2, so I have 2c plus 21. There are no like terms left, so that is the simplest my expression can get. Once again, when you see something like this, 2 times x plus 7, okay, minus 3, or let's even do it easier, minus 2x, okay? What we are going to do, we are going to say, hey, I've got one number times a bunch of things in parentheses. I'll just multiply that number times each, 2x. I'll drop my plus down, and then I'll do it again, 2 times 7. 2 times 7 is 14, minus 2x. Now I can simplify my like terms. 2x minus 2x, well, those add up to give me 0. And now I've just got 14. You see how simple that was? So that's the way you use the distributive property. Feel free to back the video up if you need to and watch it again. Okay? Now you're going to do a couple of problems on your own. Simplify these 4 expressions by using the distributive property. I'll help you out with the first one. 4 times r, 4 times 3, so 4r, 12, and then that sign drops down, and then minus 3r. Okay, now you would simplify this further. So go ahead and do the rest of the 4, and we will go on to one other thing. Now we're going to solve equations. And I need to talk about this again because we have done this, but it's been a while. Remember that to solve an equation, and what that means is we're going to find the value of the variable that we don't know. In order to do that, we need to undo the operations that have been done. So I gave 4 examples, one for each of our major operations that we've worked with. Okay? X minus 4 equals 7. To undo this, to find x by itself, we would undo the minus 4. To undo minus 4, we do the opposite operation, the inverse operation, which is plus 4. Negative 4 plus 4 gives me 0, so I will cross that out. But I have to do the same thing to the other side, because what you do to one side of an equal sign, you must do to the other side of the equal sign. And what I'm left with on the left-hand side is x. What I'm left with on the right-hand side is 7 plus 4, which is 11. So I know that x equals 11. And I can test to make sure I was right, because 11 minus 4 does give me 7. Okay, let's do number 2. To undo this plus 6, I will subtract 6 from both sides. When I do that, I get that plus 6 minus 6, those add up to 0. So I have y equals 1 minus 6. 1 take away 6 is negative 5. So I have my answer. Again, I can test this. I can do negative 5 plus 6. Negative 5 plus 6 does give me 1, so I know I was right. Okay? Let's do the next one. I have 4u. I remind you, that means 4 times u. And to undo times 4, I will divide by 4 on both sides. 4 divided by 4 gives me 1, and as we discussed, 1u, we just more simply write as u. So we have u equals 16 divided by 4, which is 4. And again, you can test that. You can say, hey, 4 times 4, that does give me 16, so I know I'm good. Finally, I have r divided by 5 equals 4. How do I undo divided by 5? Well, I multiply by 5 on both sides. 5 divided by 5, I can cross-cancel those. I just get 1. So I have r equals 4 times 5, which I know is 20. Once again, you can check to make sure you got that one right. Because you had r divided by 5, if you plug in 20 for r, 20 divided by 5 did give you 4, and you know you're good. However, those were simple cases. Sometimes there are multiple operations that have been done to a variable, and so we have to do all of these, and here's the big point that I want you to remember. I have to do them in reverse order of operations. Okay? So, I gave a couple of examples, and I'm going to reveal these right here. Okay? Remember, order of operations tells me that I have PEMDAS, is the way we've talked about it. Parentheses go first, then exponents, then multiplication and division together, and then addition and subtraction together last. When I'm undoing them, I'm going to go that way. So the first thing I'm going to do is my addition and subtraction. Then I'm going to undo my multiplication and division, and then I'll keep undoing in reverse order. Okay? So, what you need to remember, undo addition and subtraction first, and then undo multiplication and division. So I've given you 2 examples here as well. First thing I'm going to do, remember, undo addition and subtraction first. I want j by itself, so I need to undo this minus 3 at some point. I'll do it first, so I add 3 to both sides. I get negative 3 plus 3 gives me 0, and I will rewrite my equation. On the left-hand side, I have 4j is left. On the right-hand side, I have 13 plus 3 is 16. Now my new equation is 4j equals 16. Well, I still have this 4 times j. And what that tells me to do, or what that tells me has been done, is multiplication. How do I undo multiplication? I divide. So I divide both sides by 4. 4 divided by 4 gives me 1. So all that's left on the left-hand side is j. And 16 divided by 4 gives me 4. And here is when it's an excellent time to go back and check your work. 4 times j, which is 4 times 4, minus 3. Well, that's 16 minus 3. That does equal 13, so you know you did it right. Now let's do this next one. Once again, I look over here. It tells me to do addition and subtraction first, or to undo those first. So I will undo this addition right over here. And the way I undo that is by doing subtraction. Subtract 6 from both sides. 6 minus 6 is 0. 4 minus 6 is negative 2. Now I will rewrite my equation. I have h divided by 2 equals negative 2. I only have one operation left. That's the divided by 2. And the way I undo dividing is I multiply by that same number. If I multiply both sides by 2, well, this 2 and this 2 will cross-cancel. They'll give me 1. 1h is just h. So I will rewrite my equation again. I get h equals negative 2 times 2, which is negative 4. And that is my answer. Let's check to make sure I was right. Negative 4 divided by 2. Negative 4 divided by 2 will give me negative 2. And so I get negative 2 plus 6 equals 4. Negative 2 plus 6 does give me 4. So I know I did it correctly. Okay? And that's all we've got. So what we are going to do now is I'm going to let you try a couple two-step equations using reverse order of operations like we just did. Go back and rewatch it if you have to. And then what we're going to do is we're going to combine like terms to solve algebraic equations. Okay? So we're going to try to put everything together that we've just talked about in section 7.1. Okay? So the first thing I'm going to do, I'm going to say, hey, 9x minus x, those are like terms, and I know that this is a 1 right here. So I have 9 minus 1 x's, and that's going to equal 136. Well, 9 minus 1 is just 8, so 8x equals 136. Now I have this 8 times x. How do I undo times 8? I will divide by 8 on both sides. Divide by 8. I get 136 divided by 8. And 136 divided by 8, I just used a calculator because I don't know it off the top of my head. And that gives me 17. X equals 17. If I plug back in, 9 times 17 minus 17, and I put that into a calculator, I do in fact get 136, so I know that I have not made a mistake. One more time, we're going to combine like terms. We're going to combine this negative 3p and this positive 8. So I get negative 3 plus 8, those are all p's, is going to equal 60. Well, what's negative 3 plus 8? That's 5, so I have 5p is equal to 60. And now I have 5 times p. How do I undo times 5? I divide by 5 on both sides. 5 divided by 5 gives me 1. So I just get p is equal to 60 divided by 5, which is 12. Going back to check, I do negative 3 times 12 plus 8 times 12. Does that give me 60? Well, that's negative 3 times 12 is negative 36, plus 8 times 12. Negative 36 plus, that is 96. When I add those together, I do get 60, so I know I did it correctly. Now I'm going to let you practice with simplifying these. You need to combine your like terms and then solve for the variable. And then we are done, because we are not doing an exit ticket when you're not in class. Okay, that's all for the video. I will see you tomorrow.